Today we're going to do some examples and we'll have some quiz questions on the product rule, quotient rule, chain rule, implicit differentiation, and related rates. Okay, we're going to start with a review question, a question that doesn't require the rules that I mentioned, it just requires the power rule. So remember the power rule for differentiation is as follows. When we take the derivative of x to the n, that's equal to n times x to the n minus 1. So the example is similar to an example that we had on the previous quiz. It's just that I just wanted to review this. Here's our example. Okay, we have a quotient, and notice in the denominator we have only one term. Okay, so when we are in this situation, we can divide by that one term to get a sum of powers. So we'll divide the numerator. All right, so we have y is equal to 5x to the 10 minus 2, that's 8, minus 2x to the 3 minus 2, x to the 1, plus 3 divided by x squared, that's 3x to the minus 2. All right, so now we've written y as a sum of powers, so now we can take the derivative, dy dx. That's equal to 40 x to the 7th minus 2, derivative of 2x is 2. And then we're going to take the derivative of 3x to the minus 2, multiply 3 by minus 2, so we have minus 6x to the minus 2 minus 1, that's minus 3. All right, so that's our derivative. So now you're ready to do problem 1 on the quiz. Okay, so here it is. Just pause the video and copy this problem, copy number 1. All right, next we're going to look at two differentiation rules. Okay, just again a little bit of a review. All right, so here's the product rule. It's as follows. Here we have a product and the derivative of the product. So that would be the first function times the derivative of the second plus the derivative of the first function times the second. Okay, and now we have a quotient rule. If we have a quotient and we're looking at its derivative, the derivative will be a quotient with the denominator squared in the denominator. And here, copy over the denominator, multiply it by the numerator squared, minus the derivative of the denominator times the numerator. All right, so that's the product rule and the quotient rule. So we're going to start with the following example. We have, we want to find the derivative dy dx, and we have y is equal to 5x cubed plus 9 divided by 3x squared plus 1. All right, so we're going to do the quotient rule, basically just going to follow the second rule over here, the second formula. We start with the denominator squared. That's g squared, so that's 3x squared plus 1. Then copy over the denominator right here. And then here we have the derivative of the numerator. Here's the numerator. The derivative is 15x squared minus, and here we have the derivative of the denominator. That's this, 6x. The derivative is 6x times, this is the numerator, f, the numerator. It's right there. times 5x cubed plus 9. And that's it. Just leave it like that. Okay, in our next example, we again want to find dy dx. And here we have our function y is equal to 3x to the 5th plus 2 times 4x cubed plus 7. And we're dividing by 5x to the 4th plus 10. So again, we're going to use the quotient rule. This is a quotient, so we have dy dx is equal to g squared, or the denominator squared, goes in the denominator. Okay, that's g squared, and copy g over here. And here we put the derivative of the numerator. So here I need a lot of room for the derivative of the numerator. Okay, so let's copy it over here. So the derivative of the numerator, we need to use the product rule for that. This rule here, the product rule. All right, the first times the derivative of the second plus derivative of the first times the second. Okay, so let's remember that. And we'll go ahead and fill in over here. So here we have the first, 3x to the 5th plus 2. Times the derivative of the second, that's times 12x squared. Plus the derivative of the first is 15x to the 4th. Okay, it looks like I need a little more room here. Okay. All right, so that's the first times the derivative of the second, derivative of the first times the second, times 4x cubed plus 7. Okay, so what we did so far was gf prime minus f, which is this entire numerator, times g prime. Okay, so I need a little more room here. Just a second. I'm going to move this over. Okay, I got a little more room. So this is, again, this is g f prime minus g prime. Okay, the derivative of the denominator, that's 20x cubed. F is just copy over the numerator over here. So we'll copy it over. We have 3x to the 5th plus 2 times 4x cubed plus 7. Okay, so that's dy dx. And now you're ready to do problem 2. So let me show you that over here. Copy that, pause the video, and copy over problem number 2. Okay, let's look at this following problem. Here we have y equal to x squared minus 6x plus 9 over x plus 4. And we want to find the x values where the tangent line is horizontal. All right, so remember that horizontal, that means slope 0. All right, so we want to find the slope of the tangent line. When is the slope of the tangent line equal 0? So that's the same as asking when is y prime equal to 0? Remember, y prime, the derivative, gives us slopes of tangent lines. So we have to first find y prime and then set it equal to 0. Now y prime's a quotient, so we're going to use the quotient rule. So let's find y prime. Y prime, I could have written dy dx here or y prime. Okay, in the denominator we have the denominator squared, x plus 4 squared. Copy the x plus 4 over here. Here we have derivative of the numerator, which is 2x minus 6 minus the derivative of the denominator, which is just 1, times the numerator, x squared minus 6x plus 9. And we want to know, when is that equal to 0? We want to solve this. So first we'll have to simplify this numerator in order to solve this equation. So let's do that. Let's simplify the numerator. Okay, so this is equal to, let me pull out a 2 here just to make this multiplication easier. This is 2 times x minus 3, so just factoring that. Alright, so now we have x plus 4 squared. Multiply this, I'm going to put the 2 in front, and we multiply and we get x squared. And then we have 4x times 4x plus minus 3x, that's plus x, minus 12. Alright, so I just multiplied x plus 4 times x minus 3 to get this. Okay, and then we have, I might as well open the parentheses here, minus x squared, then minus minus, that's plus 6x, and then minus 9. All right, multiplying through by 2 here, we have 2x squared plus 2x minus 24. All right, let's combine our like terms in the numerator. We have 2x squared minus x squared, so that's x squared. 2x plus 6x, that's plus 8x. And then we have minus 24 minus 9, so that's minus 33. And we want to know, when is this equal to 0? So remember that a quotient is 0 if it's in lowest terms, and this one is if the numerator is 0. So basically we just want to set the numerator equal to 0. Let's try factoring that numerator. Okay. All right, so we have 33 is 3 times 11. So if we have a plus 11 and a minus 3, our middle term does come out to 8x. We have 11x minus 3x, which comes out to a positive 8x. All right, now we see this is in lowest terms. There's nothing we can cancel here. So this is 0 when the numerator is 0. So that's when x plus 11 is 0. That's when x is equal to minus 11. And when x is equal to 3. So these are the two places where the tangent line is horizontal. This is where y prime equals 0, or tangent line horizontal. Okay, so now we can actually take a look at the graph. I'm going to show you a picture of the graph, and you'll see that from the picture of the graph it does look like the tangent line is horizontal at these points, x equal minus 11 and x equals 3. So let me show you that. Okay, here we have a picture of the graph, and let's see, it says that the tangent line, if you look at it, the tangent line seems to be horizontal here. It's usually at the high points and the low points where the tangent line is horizontal. This seems to be one place with a horizontal tangent line. That's a low point. Sorry, that's a high point. And this is a low point of the graph right here. About here, the tangent line seems to be horizontal as well. Okay. What are the x values here? Well, here, this x value seems to be between minus 8 and minus 16, so that must be the x equal minus 11. And this x value, it's pretty close to 0, to the right of 0, so that must be this one must be the, right here, this must be the x equals 3. And this one over here, that must be the x equal minus 11. Okay, so just verifying on a graph. I took this from an online graphing calculator. So using that online graphing calculator, we can see that it does make sense that these are the x values where the tangent line is horizontal. Now you're ready to do problem 3. So let me show you that. Let's do that. Okay, let me just get that here. Problem 3. Okay, so pause the video and copy the problem, and you can do problem 3 now. The last derivative rule that we used is called the chain rule. And here we have two ways of writing the chain rule. The first, the chain rule applies to a composite function. So here we have a composite function. We have f, and inside of f we have g of x. So we would read this f of g of x. To take the derivative of f of g of x, and remember we consider f to be the outer function and g to be the inner, we take the derivative of f, that's the outer function, times the derivative of the inner function g. That's one way of formulating the chain rule. Another way is you can think of it as follows. Let's say we have y where, so y is our function, y, and let's say y is a function of u. Okay, that's our variable. And then u is a function of x. So if you substitute in the x expression here, you have y as a function of x. Okay, so sort of like we did over here, we substitute in g of x into f of x. But read this as y is a function of u. In other words, y is a function whose variable is u. U is a function of x. U is a function, and our variable is x. So what is dy dx? Well, dy dx is, first we do dy du. We take the derivative of this, and we multiply by du dx. We multiply by the derivative of this. So we'll be using both forms of the chain rule. We'll start with the top form of the chain rule. All right, so let's do an example. So in our first example, we have y is equal to 5x to the 10th plus 30. And that's all to the 7th power. So in this case, our outer function is the brackets with exponent 7. That's our f in this expression. And our inner function is 5x to the 10th plus 30. That's our g that's substituted into f. Okay, so we have, just breaking it up, we can think of that as our outer function. If you want, for a variable, we can put a variable u in there, but I'll just leave it blank. And our inner function g, that's equal to 5x to the 10th plus 30. So we have the outer function, the inner function. Okay, let's find dy dx, or this derivative. Okay, so I'll write y prime. No, you know what? Let me write dy dx to emphasize we're taking the derivative with respect to that, and that's our variable x. So we do f prime of g of x. That's the derivative of the outer function. Okay, so let's do that. That's just a power rule. That's the derivative of the outer, and put g of x in there. So we just copy this over, the inner function over right here. Times the derivative of the inner function, g prime of x. See? Take the derivative of the inner function, put it right here. So that would be 50x to the 9th goes here. All right, so that's a simple application of the chain rule. Okay, so that's our first chain rule problem. Let's do another one. Okay, here's our second example. All right, so here we have y is equal to, then 3 in brackets 3x plus 5x to the 10th plus 30. Sorry, let me make that 30. Let me make this to the 7th. And here I'll put 10. Exponent 10. All right, let's figure out dy dx. The outer function is bracket exponent 10. We could think of this as the outer function. All right, we could put a u in there if you want to put in the variable. So first the derivative of our outer function, so that'll be bring down the 10, so we have 10. Change the exponent to 9. Copy over this inner function exactly as is. And now we have to multiply by the derivative of the inner function. So right here, let's multiply by the derivative of the inner. I don't really have room. I'm going to write it here. This is multiply by. All right, and so we're multiplying by derivative of 3x plus the derivative of this, which calls for another chain rule, so that would be 7, 5x to the 10th plus 30, and change that to 6, and now multiply by the derivative of that inner function, so that's 50x to the 9th goes right here. Okay, and there we have our derivative. So that's the, again, this part's the derivative of the outer function of the bracket 10, exponent 10, times the derivative of the inner function. These are multiplied together. Okay, I put them on separate lines, but they're multiplied together. That's 3 plus the derivative of this piece, which is chain rule 7, inner function, exponent 6, and then derivative of the inner function, which is 50x to the 9th. Okay, so that's a more complicated chain rule because we did a chain rule within a chain rule. Okay, the derivative of the inside required a chain rule as well. Okay, now you can do problem 4. So let me show you that here. Okay, here we go. Here's problem 4. All right, so copy it down and pause the video, copy it down, and you can do that right now.